Chapter 20 Organic Chemistry. Organic chemistry means studying about organic compounds. Organic compounds contain all organic compounds contain carbon. That does not mean carbon monoxide, carbon dioxide, or carbonates or carbides are organic. They are inorganic. So organic compound mostly almost all of the organic compound have carbon, and they also have other elements like hydrogen, oxygen, nitrogen, phosphorus, sulfur, etc. As organic compounds contain carbon, they have different type of bonding patterns. They can have chains, rings, or multiple bonds, and also they are generally covalent compounds. We know carbon is in the middle of the periodic table, so they mostly form covalent compounds. They form molecular or gas liquids or low molecular, low melting solids. And they have varying solubilities, and also they are not conductive because they don't form ions. As we know, most of the organic compound has carbon-carbon bonds, and carbon-carbon bonds is a covalent bond, and they are very unreactive, and as a result they are very stable compounds. When you talk about the carbon-carbon bonding, carbon has 4 electrons, valence electron. As a result, it needs another 4 electrons to fulfill the octet rule. So that carbon will form 4 bonds with other atoms. So if carbon forms 4 single bonds, they will form 4 atoms around that. As a result, they will become tetrahedral. They also can form 2 single bond and 1 double bond, and that means they have 3 groups and they will form trigonal planar. Sometimes they also can 1 triple bond and 1 single bond will make the molecule a linear molecule. In the organic compound, the biggest group is considered as hydrocarbon. As the name indicates, it's hydro means hydrogen and carbon means carbon. So they only contain hydrogen and carbons. So these hydrocarbons can be aliphatic or aromatic. So aliphatic means they can be chain or single molecules, but aromatic means those molecule has some type of aromatic compound such as benzene. We'll talk that in later. So hydrocarbon, because they have hydrogen and carbon, they are not soluble in water. We know if it has to be soluble in water, they should have some polarity, right? So because there is no polar bonds, there is no attract to water molecules. So the aliphatic hydrocarbons are categorized into 2 other groups. That means saturated or unsaturated aliphatic acids, aliphatic compounds. Saturated means they are happy, they are stable. That means they don't have any double or triple bonds. We call that alkanes because they only have single bond and they are not reactive. But unsaturated means they have double or triple bonds. The double bonds are called alkenes and triple bonds are called alkynes. So these double bonds, triple bond are very reactive. We are going to learn that later. And also they can form rings or chains. These chains can be straight or bent. So these are all aliphatic hydrocarbons. The other group is under hydrocarbon is aromatic hydrocarbon, which consists of a special group called benzene ring. Now we'll come back to the saturated hydrocarbons. So we told saturated hydrocarbons mean they are not reactive. They only have single bond. They are called alkanes. So to find whether or to draw alkane, there is a formula, there is an equation or a formula, that is C sub n H2n plus 2. That means if you want to draw alkane for a certain number of carbon, we can know the hydrogen numbers. That means the hydrogen is going to be 2n. I mean, if the carbon is n, the hydrogen is going to be 2n plus 2. So that is the alkane formula. By looking at the numbers of carbon and hydrogen, we can assume whether it's an alkane or alkene or alkyne. Now we'll talk about the unsaturated hydrocarbon. As we told, they can be alkenes or alkyne. That means they have double bonds or triple bonds. The double bonds are called alkenes, and they are considered as CnH2n. That means if you have n number of carbons, your hydrogen is going to be double the number of carbon. That means you can see from the alkanes to alkyne, 2 hydrogens are taken off and it has formed a double bond. So because you have a double bond, we can't, it has an unsaturated, or that means they are very reactive. Unsaturated other aliphatic hydrocarbon is the alkynes, which has triple bonds. The formula for that is CnH2n plus -2. So you can see you are reducing more hydrogens. So the hydrogen is lost due to formation of another bond and forms a triple bond. Now here are the pictures showing some unsaturated hydrocarbons. The top ones have double bonds, the bottom ones have triple bond. So you can see you have chain hydrocarbons with unsaturated and also rings. Okay, so that does not mean your aliphatic hydrocarbons cannot form ring. They can form ring. Okay. Okay, now we are coming to the aromatic hydrocarbons. Aromatic hydrocarbons means they have benzene ring. So what is this benzene ring mean? Benzene ring mean it has 6 carbon connected together and you have double bonds, one carbon to the other carbon. I mean they have three double bonds inside the ring. So this double bonds can resonance and they can move from one carbon to the other carbon. As a result, the double bond is moving along this benzene ring. So we draw like this, the hybrid structure for benzene ring. So as a result, these double bonds are very different from the normal double bonds because they are not stable double bond, they move. So it's a different structure than the other structure. So that's what we call that aromatic hydrocarbons. Okay, now this is the summary of hydrocarbons. You have alkanes, alkenes and alkynes. Those are aliphatic and they have no single bonds, double bond and triple bond. And aromatic, they have benzene ring. Okay, now here you can see in the aliphatic you have propane, isobutane and cyclohexane. They are all aliphatic. Or you must be thinking this cyclohexane has a ring, it is aromatic. No, there is no double bond like a benzene. So it's aliphatic. Now here alkenes, you can see they all have double bonds including the rings. And now here alkynes, you have with chains and with rings, the alkynes. Okay, now here there's the summary of all these aliphatic hydrocarbons, alkanes and the formula and an example, and alkenes the formula and the example, and alkynes the formula and the example. And we can also draw by showing their connection. Like you can see under the structural formula, you have 4 carbons connected to each other and each carbon is connected with hydrogen. So it shows the structure. So we call that structural formula. The other form is space filling, like how the atoms are filled together, that shows. So there are several ways you can show the molecular structure of an organic compound. I mean, not an organic, we can show for all the compounds. So in condensed structural formula, atoms are listed together in order and normal bonding patterns and to determine the position of the single and multiple bonds. And we use brackets to indicate that more than one identical group attached to the same previous central atom. The group listed or the bracket listed first, in which case attached to the next central atom. Also, we have skeletal formula, we also call line angle formulas, which shows each angle, the beginning and the end of the line is represented a carbon atom. Hydrogen is omitted on the carbon, but they are included in the functional groups. Multiple, like double, triple bonds are indicated as a double line and a triple. Now this is example now shows the structure. The first column is the name, then the structural formulas where you can see the bonding, and then the condense. That means we don't show the carbon hydrogen bonding, but we show the number of hydrogen. We call that condensed structural formula. The next, carbon skeleton, just show a skeleton only. You can see each connection at the beginning and the angle at the end is a carbon. There is no hydrogen shown. And then the ball and stick model, we can show with the ball and stick model, and then the space filling model. So this is another more example. Okay, now we are going to talk about the isomerism. What is isomerism means? Isomerism means sometimes in organic compounds they will have the same name but they are different structures. That means different molecule. We call that isomerism. So there are two types of isomerism. One is structural isomerism, other one is stereoisomerism. Structural isomerism means they have the same formula, but their structure is different. Their connections are different, or we call also constitutional isomers. The other one is stereoisomers. They have the same attachment. They have the same molecule, same attachment, but the spatial arrangement is different. Or the spatial, like when you look at the space arrangement, they are different. That's called stereoisomers. Now in this slide, you can see butane. You have 4 carbons and how many hydrogens are there? 10 hydrogens. And in the isobutane, you have 4 carbons and 10 hydrogens. So it is C4H10 for both molecules. But you can see here in the first one, you have a long 4 carbon chain. In the second one, you can see a 3 carbon chain and 1 carbon is in the middle. Okay, so you can see it's a branch carbon chain. So they are, how they attached is different, but their formula is same. We call that structural isomers. Now, because of these structural isomers, they also differ in their chemical or physical behavior. First, you can see here the structural isomer is, now you can see the butane, the long chain carbon, and the other one is isobutane with the branch chain carbon. You can see the difference in the boiling point. So basically it affects the physical properties.